Hello and welcome to another video. Recently, Chinese high school students took the gaokao exam, which is a really difficult and important exam. And in today's video, I'll be going through questions 1 through 5 of the math multiple choice section. I'll be making videos on the rest of the questions of the math section as well, so stay tuned for those. Okay, let's take a look at question 1. We're given two sets, set A and set B. And let's just look at set A first. So we're looking for x that satisfy x to the third is between -5 and 5. It doesn't specify that x is an integer, so technically there are infinitely many x that satisfy this. However, we are looking at the intersection between A and B, so let's look at B now. Clearly in B we only have these 5 integers, so since we're finding the intersection between the sets, we are seeing what they share in common. So we really are only restricted to these values for x. So we can just kind of eyeball this right now. In our mind, let's just plug in each one for x to the third. So -3 to the third, that's -27, which is way less than -5. So we do not have -3 in the intersection. -1 to the third, that's just -1, which does seem to be between -5 and 5. So we can include that in our set. 0, that's clear that it's between. So I'm just going to write 0. 2 to the third is 8, which is greater than 5, so we do not include that. Finally, 3 to the third is 9, which is greater than 5. So this is our intersection of A and B. So the answer is A. Let's take a look at question 2 now. We're given that z over z minus 1 equals to 1 plus I, and we need to find what z is. So I'm just going to start off by subtracting 1 on both sides. And this equals to 1 over z minus 1 equals to I. Now the problem is very simple. We just multiply z minus 1 on both sides. So the answer is C. Okay, so moving on to question 3, it looks like we are working with vectors. So we're given vector A and vector B. And we're also given that B is perpendicular to B minus 4A. Something to remember here that will help you solve this problem is that if two vectors are perpendicular, that means that their dot product is equal to 0. We're going to use this fact to solve for x. The dot product between these two vectors must equal to 0. And let's just figure out what b minus 4a even looks like. 4a is 0, 4. So b minus 4a is going to look like I will move this to the top. So now we know what b minus 4a is. So this should be easy now. We're just going to take the dot product between these two vectors. And of course you can solve the quadratic if you want, but you can also look at the answer choices here and see what satisfies this equation. It's pretty easy to tell from plugging these numbers in that the answer is D. Okay, let's take a look at question 4 now. We are given that cosine alpha plus beta goes to m, tan alpha tan beta equals to 2, and cosine alpha minus beta is what we are trying to find. These two look like we might have to expand into the sum and addition formulas, but this doesn't tell us much so far. If tan alpha tan beta equals to 2, then it is also true that cosine alpha cosine beta equals to 2, which gives us that sine alpha sine beta equals to 2 cosine alpha cosine beta. And for better notation purposes, I'm going to let cosine alpha cosine beta be x. I'm going to let sine alpha sine beta be y. So this gives us that y equals to 2x. Now let's go back to our cosine alpha plus beta and cosine alpha minus beta. So cosine alpha plus beta, if you imagine the formula for the sum of the angles for cosine, you'll know that it's cosine cosine minus sine sine. So we're going to write that in terms of x and y. Cosine alpha plus beta is going to be And I'll do the same for cosine alpha minus beta. Now I want to write some equation that can relate the two so that I can find cosine alpha minus beta, since we see this is all in terms of cosine alpha plus beta. So when I add the two, that will give me 2x. And when I subtract one from the other, that gives me negative 2y. And I'm just going to move the negative to the other side. We know what 2y is in terms of x. If we just multiply 2 on both sides of this, we know that 2y equals to 4x. So I'm going to erase 2y and put in 4x. And I will divide by 2 so that I can set the two equations equal to each other. Okay, so now I can set the equations equal to each other. I'm going to multiply 2 on both sides. As you can see now, we can solve for cosine alpha minus beta in terms of cosine alpha plus beta, which we know is m. So now we have cosine alpha minus beta in terms of cosine alpha plus beta, and we know that this is just m, so this equals to negative 3m, which is A. Okay, for question 5, we are given that the base areas of a cone and cylinder are equal, the lateral areas are equal, and they both have heights of square root of 3, and we need to find the volume of the cone. First, it would be helpful to draw some pictures. So I'm going to draw a cone and a cylinder. These are not really to scale, but it's good for helping us figure out the problem. Okay, so the base areas of a cone and a cylinder are equal. That's what we're first given. So base area, we're talking about these little circles that we see. Now, if these areas are equal, it also should be the case that their radiuses are equal as well. So I'm going to say that this is r, and this is also r. They're equal. We're given that both have heights of square root of 3. And finally, to put this into an actual equation, we have that the lateral areas are also equal. And by lateral areas, they are referring to the surface area, but excluding the bases. So that would be like the surface area of this cone over here, and for the cylinder, it would be this. So now we can put this into an equation. The lateral area for a cone is just going to be pi rs, where s is this long side over here. This is equal to the lateral area of the cylinder, and you don't really need to know the formula because you can just imagine it as a rectangle, and the rectangle's dimensions are going to be the height, which is square root of 3, times the length of a rectangle, which in this case is going to be the circumference of that base circle, which is 2 pi r. That gives us s equals to 2 square root of 3. Now that we know this, we can see that this is a 30, 60, 90 triangle. That tells us that r is equal to 3. The formula for the volume of a cone is v equals to 1/3 pi r squared h. So plugging in everything, we will get B. Thank you so much for watching. Please like, share, and subscribe.